Day 152, Honors Physics, Magnetism, example or homework problem number 20. So here we have three wires that are all 3 centimeters apart. And the only way to do that is to have them in a three-dimensional array like this, like they're three, say, fence posts or telephone poles sticking out of your paper or out of your desktop. They're all 3 centimeters apart. If you lay them flat on the paper with one wire in the middle, then the outer two wires are 6 centimeters apart. So they can't be in a plane. They got to be three-dimensional like this, perpendicular to your paper to get this configuration. All three wires are 3 centimeters from each other, forming an equilateral triangle with angles of 60, 60, and 60 degrees. So the equation for the force between any two pair of these wires is, as we have here, we developed that in class, mu 0 over 2 pi times the product of the currents times the length of the wires divided by how far apart they are. So if you do these in pairs, doesn't really matter, but if I do this pair first, I call that F1 and F2, the force that each wire exerts on each other. If they carry currents in the same direction, and I arbitrarily picked towards the floor, it didn't say towards the floor or towards the ceiling, it said all in the same direction, so I picked towards the floor. But bottom line is, when they carry currents in the same direction, whether it's toward the floor or toward the ceiling, these two wires will attract each other with equal and opposite force. And the magnitude will be down here by this equation. And they give you the currents in each wire, 16 amps, 16 amps. The length of the wire is 0.80 meters, divided by how far apart they are, 0.03 centimeters. And then you can calculate F. But all 6 F's here are the same. This pair is the same. This pair, 3 and 4, will be the same. And pair 5 and 6 will be the same. Comes out to be, well, some number, it's all the same. I'll let you calculate that number. So F will come out with some value. All right, now what you can do is pick any one of the 3 corners to solve or to finish off the problem. Try to pick the one that's the easiest. For me, the one that's easiest is the one here at the top, so to speak, this wire right here. I need to add these two vectors, F1 and F6. And I know they form a 60-degree angle because this triangle is a 60, 60, 60 equilateral triangle. But all I need to look at is either F1 or F6. I'll look at that vector by itself. I'll go over here to the side. So I've drawn vector F6 right here. I could do the same thing with F1, but it doesn't matter. Those are the same vector, slightly different directions, but same angles. For example, this angle right here is 60 degrees. You can get that from the geometry of the diagram, or this angle right here is 30 degrees. Anyways, you know what F6 is, and you know these two angles right here. So using components, using sines and cosines, you could figure out the x component, which you really don't need to figure out because what's going to happen is the vector F1, which will be in this direction, will have components F1x in that direction. You really don't even need to draw this because that F1x component will cancel out the F6x component. But the F1y component will be the same as the y component of F6. So bottom line is, I don't need to figure this out because this vector component will cancel this vector component for these two vectors that are on that top wire. So all I need to worry about is finding this component right here. And I know these angles from the geometry of the problem. That's 60 there and 30 there. I know this F6 from this computation down here at the bottom. So I figure out F6y, the y component of F6, which is be down. So let's just say it came out to be 15. Well, then the final answer will be 30 newtons because those two vector components are adding together. They're both in the same direction. They're not 15 newtons each. There's some other number. And by the way, I think the answer in the solution set is slightly off. It's the final answer, I think, comes out a little bit higher than what's listed on the solution set. But bottom line is, get this component, double it, and that's the answer. And then the direction for the answer would be each wire then would have a force directly towards the center of the triangle. Inward. I think the answer sheet says inward. So the force would be inward. All three will have the same answer magnitude force towards the center of this equilateral triangle.